This is the most engineered piece of paper you will never think about. 3 layers, 1 wave.
500 billion corrugated boxes produced every year. Every Amazon delivery, every fruit crate, every appliance shipment, every pharmaceutical package. Every corrugated box begins as kraft paper, brown paper made from chemically processed wood pulp. The word kraft comes from the German word for strength. A single paper roll weighs 5 tons and contains 12 kilometers of paper. The corrugator consumes one of these rolls every second. The splicer machine accelerates a fresh roll to match the line speed, applies a strip of double-sided tape, and completes the splice at full speed. The splice must be invisible in the finished product. A splice that creates a thickness variation in the liner paper produces a tone. The corrugating rolls are the heart of the machine. 2 rolls with perfectly meshed fluted teeth rotate at synchronized speed. The fluting geometry determines the strength of the finished board. A taller wave gives more cushioning. A shorter wave gives more stacking strength. The glue joining the corrugated medium to the liner paper is starch, the same material as cornstarch. Starch glue is used because the completed corrugated board is a structural sandwich, 2 flat liners providing tensile strength, the fluted medium between them providing compressive strength.
The hot plate section is 20 meters long. At 300 meters per minute, the board spends 4 seconds in contact with the heated surface.
The correct failure mode in a peel test is fiber tear. The paper itself tears before the glue bond fails. The corrugator produces board in the full machine width, typically 2.5 meters. Every customer order requires a different width. The score line is the most critical geometric detail on a corrugated box blank. It must weaken the board enough to fold at exactly the right position. The cutoff knife moves with the board at 300 meters per minute while making the cut, then retracts and repositions for the next cut, all in the distance between 2 cuts. The corrugator produces finished board sheets, flat, scored, and slit to width. These sheets are the raw material for the converting is where the flat board becomes a box. 3 machines in sequence. The flexographic press prints the graphics and text. Flexographic printing uses flexible rubber printing plates and fast-drying water-based inks. A 4-color print job, the flexographic printing plate is made by exposing a photopolymer sheet to UV light through a film negative a design, then washing away the unexposed areas to leave the raised printing surface. The die is a flat steel plate with steel cutting rules and creasing rules bent and set into precise slots cut by laser. Making a die takes 4 hours. The cutting rule must penetrate through all 3 layers of the corrugated board in a single stroke. The rule is sharpened to a 52-degree bevel angle. The folder gluer runs at 400 boxes per minute. Each box passes through 7 folding stations. Hot melt adhesive sets in 2 seconds after application. The joint must be pressed within that 2-second window. The glue temperature is 180 degrees Celsius.
A folder gluer running at 400 boxes per minute produces 24,000 boxes per hour.
Box compression strength, BCT, is the primary quality specification for every corrugated box. It tells you the maximum load a box will carry before it collapses. The box fails in a characteristic pattern. The top corners buckle first, then the side walls fold inward, then the top panel collapses. Burst strength is the quality specification that governs how rough a box can be handled in transit. A package thrown by a courier. A carton dropped from a conveyor. Edge crush test tinant ECTS strength replaced burst strength as the primary board specification in the United States in 1991. The corrugated box was designed to be assembled in under 10 seconds, filled, closed, and shipped. The design that achieved 8 seconds, that is the average time a trained packer takes to erect, tape, fill, close, and label a corrugated box. The record in competitive packing events is 4.2 seconds. The on-demand box-making machine produces a box sized exactly to the product being shipped. No void fill, no English. The 3D measurement system captured the product dimensions to within 5 millimeters in all 3 axes. The box calculation adds additions.
Corrugated boxes have the highest recycling rate of any packaging material, 91% in the United States, 85% globally.
The hydropulper breaks the recycled corrugated board back into fiber in 20 minutes. The resulting pulp slurry is 98% water. The paper machine is the fastest large machine in manufacturing, running at 1,000 meters per minute.
The corrugated box is the most engineered, disposable object in manufacturing. A packaging engineer designing a box for a pharmaceutical finite element analysis, the same computational method used to design aircraft structures and bridge supports, is now standard in corrugated packaging engineering.
The point-of-sale corrugated display is the most design-intensive application of corrugated packaging. A display must be strong enough to hold 30 kilograms of product. Ventilated corrugated packaging for fresh produce is engineered to a completely different specification than shipping boxes.
The corrugated tray holding these strawberries was designed by a female South Asian engineer who spent 3 weeks optimizing the ventilation.
UN-certified corrugated packaging for hazardous materials must pass a series of destructive tests: drop test, stack.
The UN drop test simulates the worst-case handling event in normal shipping: a box falling from chest height onto a hard surface.
200 meters machine, 200 meters of machine, 300 meters of board per minute, 21 days without stopping. This is the corrugator, the machine.
Every van on this street is carrying corrugated boxes. Every building on this street has received corrugated boxes today.
3 layers. 1 wave. 500 billion times a year. The most engineer.
The next box that arrives at your door, Saint, you will look at it differently. For about 10 seconds. Then you will throw it away.